Hey everybody, this is a little weird talking to you, but you're not there. I'm talking to my computer. But anyway, today we're going to start circuits. Just a fair warning, I am not going to spend time editing this video, so there may be some mess ups and I may have some misspellings, but that would be no different than every day in class. So anyway, let's start with circuits. We're going to start with drawing them today, and we're going to keep this simple. This is a wire, so any straight line is basically a wire. Now, a voltage source or a battery looks something like this. It can either be long then short, or it can be like sometimes you'll see it like double. I don't know why they do that, but they do. What you do need to remember is that this long end is the positive and the short is the negative. Long is the positive, short is the negative. So this is our voltage source, or it could be the battery if we were building circuits for reals, but that's the battery. There's some other things, such as a resistor. That's a little aggressive there. Sorry about that. Resistor, if I were to draw it neatly, would be something like that. Doesn't really matter how many squiggles you get. Sometimes I just go a little crazy and go like that, but you'll notice a resistor. So that's a resistor. All a resistor does is resist the flow of charges. So the more resistance, the less flow. Some other things we have. You could probably take a wild guess that that is a light bulb, which is also a form of a resistor, especially the incandescent bulbs, which created friction, which we saw as light, so it's resisting the flow. There is a switch. That's an open switch, but it's a switch. We will be doing that later in the topic. And then some other things you need to know would be like an ammeter. An ammeter measures amps, surprise, surprise, but it measures the current in a certain part of our circuit. And a circle with a V is a voltmeter. And guess what that measures? Yeah, it measures the voltage on, for us, usually a resistor in particular. Now, as this unit progresses, you're going to hear me talk about an analogy to water flowing through pipes because that makes more sense to people. So you'll just hear me refer to that. So in your mind, you may want to think about the wire as a pipe through which water flows. Now the voltage source is the water pump. So the more voltage, the more pumping power, the more current we can push through our circuit. Kind of makes sense. Now resistors and light bulbs, those are kind of like clogs. We'll get to a point where I'll probably be asking you which side of a which side of the circuit gets more flow, and if it has more resistance, you should just think like, wow, that's a big clog. There's going to be less water flowing through that area of the circuit. So I think of resistors and light bulbs as clogs. A switch, it's kind of like a valve. It's either open or closed. Right now, that's a V, not a U. That's a V. And that's oh wow, that looks horrible. Not editing this. Valve. That looks better. Anyway, right now that switch is open, so there would be no current flowing to that area of the circuit because it's open. It's not completing the circuit. And we have ammeter and voltmeter. So these are the basics. And I'm about to delete this screen, so if you want to pause it and write some more stuff down, you can, but I'm deleting. Now let's talk about series versus parallel. So series, you're going to be hearing that a lot. These two resistors are either in series and parallel. What are the rules for series and parallel? But in my opinion, identifying series and parallel first is kind of important. So we're going to spend a little time today doing that. So these are three resistors in series. It doesn't always have to be three, but I'm just doing three. The most important thing to realize is as the current comes in here, it has no choice. It must keep going through each resistor. There's never a chance to break off. Now, I is current. I don't know why, but I equals current, and it's measured in amps. which is the letter A. Okay. So something important to take away from this is that in series, the current has no choice where to go. It must flow through each of the objects in series. So in series, current, if I could spell current, has no choice where to go. Like it can't break off and go somewhere else, and must pass through each object, in this case, resistor. Each resistor. Now, when we talk about current, it's weird because we have to say, and yeah, I'm like putting an asterisk here, conventional current, that's what it's called, conventional current. Again, I cannot spell and I will not be editing. Current is the flow of positive charges. Now, I know we just came from a unit where we're not supposed to talk about that kind of stuff, but conventional current is the flow of positive charges. Flow of positive charges. We know this isn't the case. It has something to do with Ben Franklin. He got it backwards, and we've kind of stayed with that. We've stayed with that idea that it's positive charges flowing, but we know positive charges can't move, and that's the flow of electrons, but we just pretend like it's positive charges moving. So there's that. So that's what series looks like. Now, parallel. Now, when you do a parallel, the current comes in, and then there's a junction. So I'm going to label that as a junction. And it has a choice. Maybe it'll go up here and go to this resistor. Or maybe it'll go here and go to this resistor. But the current comes in, and then it splits. Some of it might go around this way. My cat is currently going crazy. Killian, what are you doing? Some of it might go this way. But then the red and the green add up back together, and they become blue. So parallel, the current splits at a junction. Current splits. That's important to know for later at a junction. And that's basically the difference between series and parallel. There's going to be more rules to follow, and as I'm guessing we're going to be doing some online labs, I'm hoping... Sorry, my phone was just going off. This is so distracting. But as we get through more online activities, we're going to develop the ideas that go with, like what are the rules for series, what are the rules for parallel. We'll spend some time reviewing all of that and putting that in one place so you can then apply the math and skills for that later. All right. So I'm about to delete this screen, and here we go. All right, I'm going to draw a circuit. Simple circuit. Let's do this one, where there's resistor A and B. Okay. First thing I'm going to do is I'm going to trace the current going around this circuit, starting from the positive. Now remember, this is the flow of positive charges. So a positive would be repelled by the positive end of the battery and go around to the negative. So it'll go like this. And around. Doesn't matter where you break the arrows up. I'm just drawing them like that. But hopefully you saw this and it wasn't too difficult to see that A and B are in series. That was easy, right? The current never had a choice where to go. So draw another circuit. We'll make it a little bit tougher. Let's do this. There we go. Resistors A, B, and C. Now, I mean, if you want to pause right here, you could pause the video and think to yourself, what's in series, what's in parallel? Give you a second to think about pausing. And now you're back if you paused it, but I'm guessing you didn't. You should pause and think, though. Just throwing it out there. I'm going to start tracing my current. It goes through A, and then it reaches a junction where it splits. Some of it can go this way. Some of it can go this way. And then it rejoins and becomes red again and goes back around. So what you hopefully said was that B is parallel to C. And by the way, there's no correct way to write this. You're never going to be asked to write this out in the future, like, please write what's in series, what's in parallel. No, you need to just look at it and know, and then apply the rules of series and parallel. So I'm just writing B parallel to C. Now, we've taken care of this region here. And what you should realize is that when the current comes out, it goes through A and then it goes through BC. So don't overthink this. That means that A is in series with BC. I'm just calling it like the BC region of the circuit. Let's try another one if that's okay with you. So should we make it tougher? I'm making this up as I go. What's a good one? Let's try this one. Okay, we'll go with this one. Don't worry, the circuits will get much worse than this. Remember, our goal here is only to identify series and parallel. What's in series, what's in parallel. You will become experts at this. I am confident. Here's resistor A and B. I'm going to go with CD here, EF here. Something like that. If it helps you, trace the flow of the current. Starts here. Oh, we reach a junction. When you hear junction, you should be thinking parallel. Some of it goes up and around, some of it goes down, over, it rejoins, and now we're here, and there's another junction. Some of it goes through here, and some of it goes through here, and afterwards it rejoins, and for some reason becomes red current again. By the way, the current does not always flow clockwise. I just have a habit of drawing in that way. So it would be nice if you pause this for a second and just thought to yourself, you know, what's in series, what's in parallel. If you can start reducing regions of the circuit, like we did in the previous one, we said that, oh, B and C are in parallel with each other. That area is in series with A. So, did you pause it? I have no idea if you paused it, but let's go through this. It would be nice if you pause it. Give it some thought. What you should see immediately is that A and B are parallel to each other. So I'm just going to write, I'm just jotting notes down. A parallel to B. Hopefully you also saw that there's a junction here, which means there's some parallel going on, but before you can deal with that parallel, you have to say that these two are in series and these two are in series. So EF is in series, CD is in series. So now we've kind of like reduced this down to some regions of the circuit. What color we got going on here? I don't know. Going with that. Hopefully, if you think about it, now you have the CD region and then we have the EF region, and you notice that they are parallel to each other. So I'm just going to write CD is parallel to EF. And hopefully you also see that if now we've reduced this down to one region, the CDEF region. So we have the AB region here. I'm running out of colors here. We have the AB region here, and we have the CDEF region here. These two regions of the circuit are in series with each other because a current comes out and it goes into the AB region. Then it continues on and goes through the CDEF region. So if you want to say that like AB is series to CDEF, that would be fine. Now, please understand that we are not going to be writing it as you see all over this screen where you're just saying what's in series, what's in parallel. This will become second nature. it will be integral into your ability to reduce circuits, find currents and voltage. It'll become second nature. But I think it's important enough that on the first day we do circuits, we actually spend some time identifying series and parallel. That's the video for this. If you have any questions, please don't hesitate to send me an email and I will get back to you. And check your email for, which you've probably already read because it has the link to this video, for the homework and associated handouts. I hope you're all doing well. I don't miss you yet, but I probably will soon. So, looking forward to talking to you again, even though you're not here. Bye.